on this computer. Okay. So if you already opened the Blackboard folder, SAS Exercise, first I uploaded one data download and you all did it. You already did it, right? Still I'm showing it. You are familiar with words. So, for example, my research question is to examine the role of firms' accounting and stock market performance on CEO compensation. This is my research question. I picked that one intentionally because we did CEO papers and we have these nice, readily available data from words. So my research question, Rose, please.
Yeah, I'm gonna mute myself because I think when I'm typing, it makes noise. You think I'm
Oh,
asking?
okay. Okay. Yes, please. But feel free to raise your hand and talk.
Okay.
Okay. So my research question is the association between the farm financial performance and CEO compensation. Again, last night we learned how to write the hypothesis. I'm always careful not to claim causal relationship unless I do some other advanced level um, test to deal with endogeneity. But let's say I'm just trying to figure out the relationship between farm performance and CEO compensation. I didn't write all these things, but you already have the idea in your mind. What will be the dependent variable or Y variable? And I guess Tatiana discussed it in one of the class when we just discussed a little bit about what, why, how, research model. So our Y will be CEO compensation. X will be farm performance. And for farm performance, we can define farm's profitability, that means operating performance, and farm's stock market performance, say stock return. And then we'll have control variables. You can follow me, right? So I'm testing farm performance and CEO compensation. So what I did here, I did all these steps. I went to CompuStat and I downloaded, you know this part, that's why I'm not showing it, but you will have these things. So I downloaded the data from 2010 to 2020, and then I used entire database. If you use CompuStat, always start as much as you can, right? So you start with the entire population, and then I selected these 10 variables. If you want, you can do that now. But I already did that. The data are already there. So I selected these 10 variables from CompuStat. So you see, you are familiar with this variable: total assets, sales, long-term debt, income. So there are two types of income. NI means net income. IB means income before extraordinary item. Most of the papers use income before extraordinary item because it's kind of more smooth measures. Otherwise, net income might have some unusual non-occurring items. So that's why income before extraordinary item. And I just took a crude measure, closing price, end of the year, annual closing price. You can also go to crisps and you can take daily price or average price. But I took, even CompuStat has price, beginning price, closing price, high and low price at the end of the year. Because CompuStat has two types of data, annual and quarterly. I use the annual data. So now I took closing annual price and I also kept industry classification. I downloaded it as SAS. So I have one group of data. Then I went to execute comp and then I clicked on annual compensation. And then I took this data. So I didn't took too many compensation variable. They have equity compensation, right? Different type of stock options, cash compensation, salary. I'll focus. I checked bonus, but I didn't do any regression with bonus. This is, you can see it, but this is called total compensation, which captures everything: salary, bonus, which cash compensation or equity incentive compensation. Then what I did, I also have gender, CEO title, and CEO age. You cannot see the rest of the variables. So I have 11 variables. And then I downloaded that. So I will show SAS from here. Okay, so what I did, I just showed you, I downloaded two data. You already know that. Remember last time when we are in person, you guys did some download and saved it. So I downloaded those and I created a SAS library. And those data are there. So you also say those are the raw data. So what I'm going to do, I'm closing my SAS. What I did, I will open my SAS and I will show it. You will also see the coding there, right? Let me stop sharing. So now what we will do, everyone, please, if you want to open your SAS, that would be great. And then you can download the data. Camfu, are you able to download those two SAS files from Blackboard?
Yes, I had that already.
You downloaded already, everyone. And then you know how to save it, right? So let me share my SAS. Let me share my SAS. You already did some SAS work. So what I did, I created one folder here. You can create it. So if you right click new, you can name it. I already did it, but I can still show, for example, new. And then I can hide this zoom bar is blocking my screen. And then you can name test, or I named it FN 930. So you can name it. Remember, you have to use underscore. You cannot use any space. And then where you want to save your data. So you have a folder, right? So you will show that one. Enable startup and then where? Because these are some other folder, but I saved it here. 930 SAS exercise. So if you create a folder on your desktop, hard drive, downloaded the data, you can connect that folder. So whatever the data you save there, whenever you will click on that folder, it will open up. Right. And then always do enable at startup. So this is how you are creating a permanent folder. Rose, are you following? Do you have that folder, right? Yeah, okay, great. And Tatiana, I know, Arun. So then what I did, you have these. Then I said that if you see my Word document, I didn't list much, but I just said that you save the data in your permanent folder. Let's call it FN930. That's my permanent folder. But when I play with the data, because I have to merge CompuStat and execute that means all financial data and CEO compensation data, I have to create some variables. So I will copy paste the same data set and save it in work folder. Work is a temporary folder. So you will see here, if you see my Word document, you will see all the steps. Do you see my Word document or SAS? So let me stop sharing. So what I'm doing, maybe if I can share screen. Look here, what I did, like whatever you have here, you just copy and paste from the permanent folder to work folder. Right. And then we will edit the work folder. And then we need to create like dummy variables for industry fixed effect or year fixed effect. We need to scale all the variables. We need to check if there is any missing data, and we need to winsorize, or we need to, what do you call, truncate, outlier checking. So we will do all this. So I have all those in the Word document, but now I'll show it on SAS. if you open my SAS coding, then you can also run the coding, and let's see if you can see same output. So what I'm doing now, I already opened my SAS coding and I already copied and pasted those since I already ran that last night. So I will delete everything. This is my work folder. Okay. So I'm deleting everything from my work folder as if I'm just starting. I have this permanent folder. Oh, can you see it? Sorry, I'm not sharing it. Can you see what I'm sharing? You can see it, right? Can you hear me? Okay, yeah. Yeah, so I thought like you guys are like so quiet. So here, what can you see my screen? Because I'm going back and forth Word and SAS. What do you see
Yeah,
on my
we see your SAS data.
Okay, and can you see my SAS?
Yeah, that's what we're
Okay.
looking at.
I
Oh,
do have a
great.
question
Yes.
though. The coding, where did you get it from? I was trying to do the connection.
Which coding? This coding?
Yeah.
No. Oh,
That's
this
the one.
coding.
That's the
I
one
wrote
you emailed us, right?
this one. I wrote it. I wrote it last night for you guys, and you can use my coding, just changing the variables. Now I will go through the coding. I'll run every coding and I'll explain what the coding means and how you will end up with results. And the coding is also in Blackboard. You guys see the coding on Blackboard?
Yep.
Erwin, you got it? Campu, I
Yes.
so if you look at the SAS exercise folder, you will see first the data download document that I showed you. Then I have two data sets, right? So you just open the raw data. Final data is after we created all the variables. Don't download or use the final data. You will create it now, the final data. Just download and save compose.raw and execute raw. And then I'll also share you the Excel file. But if you see SAS exercises, Arwin, you got that SAS exercise, Tatiana?
Yeah, I got the SAS exercise.
Can you run it or open it? Then you will see here this coding. So everyone can open this coding.
Yep.
Um. I don't see about this one.
It's called raw table.
No, how to open coding? You know what? When you are on SAS here, you downloaded the file, right? So
Yes.
you see here, open program. You
Okay.
see on top of open program. So
Okay. I have to refresh my SAS again.
sure.
Beg a little bit, Professor.
Yeah, please. I need to make sure everyone can follow me and do it. We will go very slow.
Okay. Go to File. Open the program.
Open the program. Now, if you find where you save the coding, I have SAS exercise. You see,
SAS Exercise.
where did you download it or
Okay.
save it?
SAS Exercise all from the backboard. Oh, I forgot the download for this one.
Yeah, you first download
Uh,
from Blackboard, right, and save it somewhere. Maybe you make a folder FN
I
930 or something.
SAS Exercise. Yep. Okay.
Mhm.
I have to go to the SAS Exercise.
Mm.
Okay, I saw that one and click OK, right?
You click on that. You see the
Yeah.
program looks like someone is running because we use
Mm.
the run command, right?
Yes, I got it, Professor.
You
Mm.
got it. And
Mm.
then you click on SAS Exercise and you open it.
Mm.
Now you can see my coding, right? On your computer, not the screen. You can open
Yes,
on
yes,
your
I got it.
Okay, great. Arwin, are you able to open my coding? Okay, good. Rose, Tatian,
Yep.
you all can open my coding. Great.
Thank you.
Okay, you're welcome. And pretend that you have nothing. Your work folder has nothing. Right. So now I'll go over the coding. I know you are using your own SAS and you also need to look at the Zoom screen. So feel free to interrupt if you need to go back and forth. But I will show what I did and gladly it's being recorded. So we can also save that. So what I do, first, I have this permanent folder. Do not download the final file. You will create the final file now. So what I usually do here, these are, yes, Rose.
Oh, I'm
Okay.
good.
Okay, so what I do, there is coding to open it and show the path, but the shortcut is I just see control. These are the two data sets you downloaded. So control C. This is my permanent folder, FN 930. And then I paste it here in the work folder. You can do that, can you? Rose.
Yes.
Okay, so now everything we will be doing work folder. Work is a temporary folder. The minute you close the SAS, everything will be deleted. But I have permanent folders, so there is no like fear to lose data. So what I'm gonna do, these are all my on work folder, but I prefer to copy paste and use like an easy name. So first, I will compose-stat. You see my coding, we will create compose-stat variables. So now I will copy paste compose-stat raw data, but I just name it data1 because compose-stat raw is a long name. So let's just name it data1. Data1 means compose-stat data. So there are a couple of ways. Some people, they want to merge all data first. Some people, they want to create variables in each separate data sets and then merge at the end. So I prefer to create variables in separate data sets and then merge. So first we will create compose-stat variables. So now I'm copying compose-stat raw. I'm just naming it data1 and I'm submitting run. That means if you click on compose-stat data, you will see what you just downloaded from WRDS, right? And if you just click here and do control N, you can quickly see total number of observations. You see my screen, 165 something. And you can also see all the columns, right? So this is my compose-stat data. And what I did, the same file, I just named it 1. And what I do, I just double click, okay. You can also see your log file. If it's clean, nice, blue, that means it's good. But I manually check, okay, did I copy the compose-stat data, renamed it correctly? So yeah, it looks like all columns are there and you can also go at the end. Yes, it's 165,615 observation. So this is how I just copied compose-stat. Now I will do everything on data1. So one thing you can do, you can sort the data. So sort the data farm and ER wise. Now if you will see compose-stat, they they have two options: download the data based on calendar year or fiscal year. So most of the papers, they download fiscal years, right? So fiscal year, they call it composted F year. And they have different identifiers. GV key is the best identifier. And using SAS is the best because if you convert it, sometimes you may lose 0 when it's in Excel or CSV. So GV key is the best. QZip has some issue because QZip, you will see here, some QZips are 8 digit, some QZip are 9 digit. Sometimes QZip will be missing. Ticker can change. So GV key is the best thing. Now, Compustat and ExecuComp both are on the same data source, capital IQ. So both, they have GV key. But if you use a different source, for example, you are using CRISP or you are using ESG data or audit analytics or different data source, they have different identifier. So when you merge data, make sure you have same identifier because we need to merge by farm by year. So if you merge 2 or 3 data sets, all data sets should have the same identifiers. Sometimes some QZip might be 8 digit, some QZip might be 9 digits. So we need to cut the QZip, make it like that way. But here we have all GV keys. So now what we will do? We sort the data, proc sort. So how we will do this, SAS, you already know that. Proc is the procedure. Proc comment will listen to you and do the procedure. So when we do proc, then I ask SAS to do something. I'm asking SAS to sort the data. And then I have to detect which data sets SAS will work on. I say data equal to 1. That means SAS will sort this data. And every line we use semicolon. How I'm going to sort? By QZip, by year. And then run. So if I do that, that means our data is being sorted. And if you see your code is good, then you are good. So then data is sorted. You see, we have many missing QZip. We have many missing values. So since I sorted by QZip, that's why the blank QZips are coming at the beginning. So far, so good. You are good. You sorted your data. Yes, no, thumbs up. Kampu, are you good? Eric?
Yes.
Okay. So yeah, sometimes I'll check if I go so too fast. So one thing, yes, I'm also not an excellent coder. I Google every time. So what I do, I try to learn the logic of the coding. And if you have a good set of coding, this coding you can use. I prepared it for you very simple way so that you can create some variables, you can play around, you can use your own data sets using SAS. So now what I'll do, I'll make some composted variable. So you just cannot take raw variables. We have to scale the variables. For example, farm size. This is very common, log of sales. Sometimes you can use market capitalization. So I am creating these 4 variables using the raw data I downloaded from Composted. These are my proxy variables. Farm size is log of sales. Stock return, this is very raw, but I am just taking log of closing price. I have all this. So if you go there, so one easy way to do that, when I write the variables, what I do, I go to the data. You see, I'm going to the data. So what variable I want to create? For example, I want to create ROA. Right. So how I can calculate ROA? Right. So you can, there are different ways. Net income divided by total assets. Right. So I use IB. So what I do usually, I go there and then I click on the data that I want to use. For example, I will use IB. So I click on the data and you can copy the variable name. And then I want to divide it. Divide means slash. So SAS, you can do basic, plus, minus, log, division function. So I divided by 80. 80 means total assets. So this is how I am making my variables. So I made 4 variables. Those are now scaled, nice variable you can use in the regression. For example, I made size variable, stock return, just taking the log of closing price. ROA, it's income before extraordinary item divided by total asset. I created leverage. This is long-term debt, DLTT, long-term debt. You will see here long-term debt total and divided by total assets. Sometimes some paper use stockholders equity. I just downloaded only few variables from Words. You can do that. So now what I'm gonna do, you have to close the data sets and then you have to run this code. So now I'm not doing any procedure. I'm just creating some data. So I'm creating data and I want to make new variables and include that in the same data sets. And that's why I use data one, set one. That means set one means whatever I already have, and the new data set will also be the data one. If you want to create a new data set, you can say data two, set one. That means the new data set's name will be data two, and that will include the new variables. But I want to do everything on the same data sets. So I have this code, I run it. So if you run it, then you will also check it. Oh, sorry, because of the so this Zoom thing is like problem. I cannot see the SAS coding thing. So, sorry, are you running the code? Okay, so I ran this one, and then you will see here we created the variables. And there are several variables, those are missing because some variables are missing. That's why it ended dot. Dot means either net income missing or size missing or leverage missing, right? So now we discussed last time how we will deal with missing variables. So there are a couple of ways. If you see that you have a big data set, and then you will see that only few data are missing, then you can replace those missing data using just average. But if you see a large number of numbers are missing and you have a big data set, then you can just drop those rows, right? So I'm talking about big data set when you are taking entire composite data or creeps. So if you have big data set and so many missing observations, it's good to delete those missing observations. But if you have only 200-300 data sets and you have some missing observation, it's good to replace those missing by using the mean value. So now what I did here, if you see here, we have several missing. So and those are all major variables will be used in my regression. Either they don't have sales information or total assets, or some farms might be delisted. So what I did, I deleted those. So this is very simple. Data one, set one. I will keep everything in the data. So I wrote every instructions for you, right? So you can read, you can understand. So if size is dot, then delete. If ROA is dot, then delete. So now let's delete all those missing rows. And if you have large data sets, it's fine. Sometimes if you want to use or replace average, that might be misleading, right? Maybe the farm is delisted, right? So if you want to replicate with the average data, then it should not be good. So that's why at initial stage, if you see missing data, it's good to delete those. But when you cleaned up your data sets, only a small number of observation for a particular variable is missing, then it's good to replace it. So then what we did the missing variables. Now, if you open data one, you will see there is no missing variables for all those major variables. You will see almost all numbers are there. Then I finished all my variables. Then you see here, data one, set one, I created year. You know why? Because now I will create CO compensation variable, and then I will merge compustat and execute data. And I need to merge by farm and year, but in execute year, they name it F year, but execute they call it year. So what I just did, I created one variable, or you can also rename it. There is also a code to rename. Right. Or you can just keep both fiscal year, F year column, and I'm creating year variable. So year means fiscal year. So I did that. Now I will create CEO compensation variable. Everyone is here. You are so quiet. Are you working, following?
Yeah,
Okay.
just
Yes.
yeah,
Am I going
navigate.
too fast? Am I
No,
going
no,
too
no.
fast?
We're just navigating through, but you're recording it, so we could always go back and watch the recording and,
Yeah.
you know.
Okay, great. But if I go too fast, or if you don't understand any part of the coding, please ask me questions.
Okay.
Okay, and you can also run the coding on your computer. Did you try or just watching? Rose, I can slow down because I just
No,
want
no,
to it little bit hands-on.
I'm watching and playing, so.
Yeah, that's great. Erwin, how about you? Are you running?
Yeah, I'm running as you go.
Okay, Tatiana, you are good, and Kampu?
Yes.
Awesome. Thank you. Yes. So what I'm gonna do now here, yes. So I created like very easy steps, and so that you all can follow, you all can replicate. Now I will make CO compensation variable, and I have the raw data execute comp. The same thing. Let's keep the raw data in case you see some coding didn't work, or what the variable you wanted to make, you didn't get it. So that's why I always try to keep the original raw data and just make some working data sets, A, B, C, D, or X, Y, Z, or 1, 2, 3. So CO compensation or execute comp, I'm just copying and naming it too. And every time you do any comment, proc sort, or any proc comment, or you do anything in the data sets, I always manually check. Of course, you will see your log file. If it looks clean, that's good. And you always manually check, please, manually check. Even sometimes I use my calculator, manually calculate. Oh, I wanted to create a lag, or I wanted to take the average. Let me check, my coding looks good. So this is my raw execute comp. So you see here, you have all the CEO names, you have gender, you have their age, and execute comp data has top 5 executives, right? That top highly paid 5 executives. So that could be CEO, CFO, CEO, CLO, chief legal officer, or someone. So that's why I downloaded also this variable CEO flag, because we will just keep on the CEO variable, CEO rows, because they have like other positions, you see. And we will just play around with this TDC1 or total compensation. So this is my raw data. Now I copied that execute comp, and I'll also check total. When I downloaded, I have 141,135 rows. Now I copied it. I call it data 2. I already ran it, data 2, but I'll also check. It looks same, right? Everything is copied. And at the end, you just do control end. Control end, and you can quickly see. There is another way, proc. We will also show that to see number of observation, but this is the quickest way. You just put your cursor on the data table and control end. So looks like the data set tables are copied nicely. Now, again, I'll sort the data. I prefer to sort it, and definitely before merging, we have to sort. I did it QZip and year, but I noticed in CompuStat some QZips are missing. Let me see after sorting. No, they have all QZips, but in CompuStat some QZips are missing. So maybe GV key is better. That's why you can always use GV key for sorting, but definitely I prefer for merging using GV key. Now, you remember data 2, how many observations I have? Let's go to control end. I have 141,135. Remember, those are the firm's top 5 highly paid executives, but I want to keep only CEOs, and I have flag variable. So what I'm gonna do, I'll do a little code, keep the observations only for CEOs. So I'm doing it in the same database, data 2, set 2. Now CEO and CEO and means this one, CEO. They have also like CEO title, but this is and means annual flag. So if you click that, this is annual flag, annual CEO flag. So if this is this variable, they have nice fancy big name, but this is the SAS name, CEON. CEON, if it's CEO, that means this row is only for the CEOs. If these are blank, that means those are other officers, other managers, other executives. So what I did here in my coding, so if you have any number, you can write it. If age is 56. But if you have any text, you have to put this semicolon to make the SAS read that column. So I said if CEON is semicolon blank, that means nothing, then delete. Or you can say if CEON is within semicolon, if we write CEO, then keep. So the same comment, different ways. But what I did, I deleted all those non-CEO rows. So what I did here, I did if CEO and that means the annual flag is blank, this semicolon and I put blank, then I will delete those. Now I'll run that. I am having some problem because of the bar. How can I hide the zoom bar? Okay. So, or maybe I'll minimize a little bit because of this. Yes, let me minimize this. Otherwise, I cannot see the SAS bar and my top zoom bar is covered. No, I'm just making sure that I can see SAS bar and zoom. Rose, you want to say something?
Nope, I'm good.
You are good. Oops, sorry.
No, you're fine.
Okay. No, I cannot see my SAS bar. It is hiding. It is hiding. So I'm just minimizing it so that because of the zoom thing. So what I'm doing now, I will run. I will delete all those. So you select that and you do this submit button, and then I'll check data 2. Data 2. Now you see if you go below data 2, all those are only CEOs. All those are only CEOs. And if you go at the end, it's now only 26,231 because I excluded or deleted non-CEO rows. So now I have only CEOs, 26,231 CEO farm year observation. And then I have to create CEO compensation. Very common way is to take log. Now, when you take log, sometimes it's good to do one log 1 plus because sometimes for some variables, if you see it's negative number or if it's less than 0, that may not produce the appropriate number. So either you can take log TDC 1 or log 1 plus TDC 1. It won't vary that much. So I am normalizing it because if I just take the raw CEO dollar value, those are, I guess, in thousands, dollar compensation, you will see very discrepancy. So I'm scaling it, taking it log. And now if you see, I created, you see here, this is in thousand, I guess. I guess in thousands, not million, CEO compensation. I'm not sure, but if you take log, you will see it's better. It's very normalized. So do not take any raw variables, dollar value, no raw values. If it's age, if it's rating, that's fine. But you need to normalize it, either scaling it by total assets or take log or some ways average. So normalize it. So we did it. Now, I kept two other variables because we want to control for CEO gender. Now, CEO, we have male and female. So I did these little variables because I cannot include gender in my regression because currently if you see gender, it's male, female, right? Only few female. But SAS cannot read this text and we cannot include text in the regression. So I created this. Everything I'm keeping data to set to. If gender is equal to male, you see male is a text. So I put it within inverted comma. If it's just number, you don't need to do that. Then CEO gen is 1. If this is called this, you see this upper ticker, it's not equal to, right? If gender is not equal to male, then it's 0. So I just converted it into number, categorize it or dummy variable, I ran it. After running that, every time I run, I check the data. So you see here CEO gen. Now I can use that one, CEO gender, right? So now I have this one, dummy variable, categorical data. Now I have all the variables in my CompuStat in my execute comp. Now I'm gonna merge these two data sets. And it's better to merge with GVK because CompuStat I saw many missing QC. How you can merge it? There are several ways. Proc SQL, this is very convenient way, but our data sets are very small, only few variables. So you can simply use merge comment, right? And you can create a new data set, merging the two data sets. Sometimes we also do left join. Sometimes we also stack the data. If you have like yearly data, maybe CSR data, we have in Excel file, not words, and 1 year at a time. So I need to stack data and then combine those. So that's different comments. But now we have both data, both has year, both has GPK. I will merge them by farm, by year. Merging means assume you have these composted variables or data 1. So SAS will sort all the observation. You see 84,009, 87. We lost it because we deleted the missing values. SAS will sort it by farm and year. And then for data 2, SAS will sort it by farm and year. And then SAS will merge it. For example, data 1, you have this farm. Whatever the name of the farm, you have this farm 2020. You have all the variables, then SAS will just add those conquested variables. That means for this farm, who is the CEO? What's his age? What's his gender? Everything will be merged. So the best way to merge is by farm by year. And before merging, we always sort. Without sorting, it will be messed up. So proc sort by GV by year, data 1, the conquested one. Proc sort by GV by year, data 2. So let's sort those. Those are already sorted, but I did last time with QZ. Now I'm sorting by GV key. Make sure you sort both sets by using same identifier, GV key. Now I'll merge it. I want to see a new data set. I want to create data 3, merging 1 and 2, and how I'll merge by farm by year. So now I'm merging it. I am merging it. And you can also check log file always. Since I made this coding, you may have like any error. So you can fix that. It will show error, but I did the coding and I ran it last night. So it's clean. So it's all like look good. Now, what I'm gonna do, I'll check data 3. Let's look at data 3. You see all data are now sorted based on the farm. Yes, you can ask me question. So this is the farm. I don't know the name, but it is AIR, maybe. Let's see. AIR ticker, AAR Corp. So up to this, you see, up to leverage, those up to this part was my, what do you call, up to those part was my composted data. Then SAS matched it with execute.com data. So AIR, same company, same year. You see who is the executive. This is the name, mail, and all are CEOs, and I have their compensation. Now, if I go down, you will see missing data. What does that mean? That means this farm, this year, we have the observation in execute.com, but we don't have CEO in salary or compensation information in, sorry, we have the composted information, but we do not have CEO compensation information. This is very normal because execute.com covers only top largest 3,000 farms. And composted covers all farms, publicly listed farms, not just the largest 3,000. And that's why this could be a small farm. That's why we don't have CEO information there, right? So you will see most of the times we have composted information, but we don't have CEO information. And that's very normal. But our dependent variable is CEO info, salary or compensation. So what we will do, we will delete those rows or observations that we don't have CEO compensation data. But before that, I have to do one more thing to check whether the data is merged nicely and whether any duplication. And I know Tatiana was doing it. She already did it. So we use no dupe key because sometimes there might be duplication, right? Because you see same year, same farm, just because another observation, we may see the row twice, right? And that's why we do this. Proc sort data. I am checking data 3 if there is any duplication. If there is any duplication, it will delete that. So the function we use is called no dupe key. And after deleting no dupe key, we kind of say like we have reasonably cleaner data. So I will call the output after checking the duplication. Any question? After checking the duplication and dropping those, I will call it final data. And I'm doing by all. So now I'm just checking if there is any duplication. So you can always see log file. If there is any duplication, they will say there that many duplications. So they will drop it auto. But we will see before checking no dup key, we had 86,200. After no dup key, it's same and zero duplication. That means we did a good job with margin. But you remember that we don't have all those farm years or farms, especially small farms, CEO compensation. So we will delete those rows with missing CO compensation. Now, it can also happen. We will play with the final data because final, we don't have any duplication issue, but the final, if we have any duplication, the final data will delete those. Now, look at the final data. Most of the time, composted variables are here. Sometimes it can happen that for some reason we have CEO data, but we may not have composted data, very rare. For example, here, this farm, there is no composted data, but there is CEO compensation data, which is very rare. But we cannot use this row because we don't have composted variables. So what we're gonna do, the merged, no duplication final data, we will delete those rows. Those have no variables, and deleting at this stage is good. At this stage, do not try to use mean. Sometimes we use mean value to replicate, but we don't know. Maybe this is very small farm. We cannot use mean salary, CEO salary. That's why it's very normal using large secondary data, stock market or financial market data to delete missing observation. So I'm doing, if size is missing, then delete. If CO compensation is missing, then delete, because those are the two major variables that we have in the two data sets. So I am running it, and then you will see we probably missed some observation because it was 86,000 something. Now it's 25,045. And it's mostly because we didn't have CEO compensation. So now this data set pretty much looks like we have all observations. Still, we will check and mean, outliers, max, mean. We will do that. But now final data set has pretty much everything. So what I do, I cannot control myself. I feel very tempted. Oh, I merged the data. I don't have many missing values, no duplication. How about I just run a basic regression, right? I cannot just control myself, and I'm sure you too. So what I do, what I did last night, I just could not control myself, and let's do regression. This is how we run regression. There are several ways, but this is very common, simple regression. Not this is multiple, not just one variable, because I just used CO compensation, farm size, stock return, ROA, leverage. Proc reg. I'm using reg or regression procedure. There are different type of reg. This is basic. Data final. I want to use final data. Model means CO comp is my dependent variable, and these are my independent variables. So when I write the model, what I do, I go to the database and I check what will be my Y variables. I already know. CEO comp. I click there. I copy that one. And then I go back to my editor. I paste it. This is my Y value. And then I go back to the data. What are the X variables I want to take? So I want to take CEO age, gender, or in this side, I have size, stock return, ROA, leverage. I just click copy paste. So yeah, SAS is a little bit coding heavy and you have to do this typing coding. On the other hand, e-views or Stata, those might be more convenient. You just click the variables. But SAS, you just need to copy paste and write the model. So I did. And I'm running the model. Proc reg data final basic model. And then it will produce like several graph charts. There are several ways you can also compress that, not showing everything. But this is how you will read the result. Right. F value is very high, P is low, and we use pretty much all observations, root mean square, good R square, adjusted R square, all good looks, 36%. These are parameter estimation, but I want to see the regression coefficient. You see, all significant. Larger the farm, higher the CO compensation, higher the stock return. You see, these are parameters. These are coefficients, positive. There are two ways to see whether the significant or not. T-value, if T-value is greater than 1.65 or T-value is greater than 1.96 or P-value is less than 0.01, one tail, two tail, all are highly significant. One interesting thing, you see ROA. ROA is profitability. Higher the profitability, lower the CO compensation. Yes, that is kind of contradictory. And accounting performance, ROA is a pure accounting performance or operating performance. It may not detect or determine CO compensation, rather stock return, right? You see the coefficients are high. Leverage in theory, I know the result because this has been tested many times. So those are very consistent with the literature. For leverage, we have two types of discussions. So highly levered farms, CEOs need lots of skills to run the farms, high risk farms. So they can demand more compensations, right? More complicated, high levered farms. And that's what I see, positive relationship. So this is how I ran the basic regression. Now, I will add couple more. Last time I did not add CEO characteristics. Oops, stop sharing. Everyone is here. Are you running the variable? Is it working? So now let's run the variable with CEO characteristics. What's your guess? CEO gender, CEO age. What do you think the coefficient will be? Positive, negative, significant? Anything? Or run it? You tell me, please. And we'll take a break. We are almost done. I need to charge my computer. Just give me 1 second. Okay, so I just plugged in my power cable because it's almost dying. So if you run it, do you see the result? Anyone want to share your screen? Run with CEO gender and age. And let's see. Anyone please share your screen because otherwise I just need to see you are engaged and if you have an issue. Or I'll share my screen. Okay, are you guys doing it? I know it's being recorded, but if you also do it at the same time. Oh, great. Whose screen is that?
That's mine.
Oh, Tatiana, please run the reg with CEO, gender, and age. You did it, right? Yes.
Yes.
So highlight the proc reg final model.
So these are the results.
Okay, let's see what is the results. So you see here, CEO gender and age, not significant. I mean, this is confusing. Some literature says male CEOs are highly paid, but within this sample, we don't see any significant relationship. Some paper says older CEOs are paying, getting more, but we don't see these two variables are significant. Thank you very much, Tatiana. Thank you for sharing. And I'm sure you all are doing it. And oh, Tatiana, I see you did e-views. Do you see similar results when you do e-views versus SAS? Because I know when we do fixed effect model, and I and Professor Mamoon, we did a research, sometimes SAS and e-views results are slightly different, not like significantly different. You will see your coefficients are significant, signs are the same, but sometimes slightly different. And that's totally fine. Right. Okay, great.
I actually wanted to ask you about
Yeah,
the difference in results that you would get between the two.
I know, yeah.
So
You
you
got
said that the
different?
results are
Did you get difference? Did you run the same data in e-views?
no, I ran a different data in eViews, but I wanted to ask whether or not
Yeah,
if the results would be different if I were to, let's say,
slightly.
run a regression.
Uh,
Oh, only
sli-
slightly different? Oh, okay.
yes, so because what I know, I don't use e-views, but when I do results and my co-authors, they use e-views. And I have another co-author, she always uses Stata. So
Oh,
it differs slightly, but it will not change your results. Maybe the
okay.
coefficients differ slightly, t statistics maybe, but it will never ever change your result. The reason I know, if you do something like especially fixed effects and clustering, so we also do standard error clustering. I have one of the model. So different softwares use different ways, and I don't know all theoretical statistical parts, right? All the assumptions underlying the softwares. So because of those, you may see slightly different parameters. But I have never seen like completely different results that SAS is giving significant stata and e-views not, or SAS as a positive, e-views as negative. No.
Okay.
So,
I
so you are
actually have
good.
another
Yes.
question. So,
Yes.
do you by any chance know what's the difference between SAS and machine learning?
Awesome. I wish I know machine learning. Very good point. So SAS is still like, you know, uh, based on our comments, right? SAS, whatever I do the comment, I run it, SAS will just follow that. On the other hand, machine learning, for example, Python, and there are several other softwares, they are more advanced, so they will read the data and depending on different type of models, because SAS, what we do, we use only regression, right? Maybe we might have different type of regression, but machine learning has different type of models. I don't know Python, I don't know machine learning, but those machine learning based model, MATLAB or Python, they can handle different issues. For example, your autocorrelation, missing observations, or we also, our data is always noisy, right? Those type of endogeneity, those machine learning can handle and can produce the results different way. Machine learning can also produce regression, but I I I, I know different types, cluster data, like the decision tree model, for example, right? Or maybe numeric data. So there are several papers, and I am actually doing one paper with one of our computer science professors. Same CEO compensation. We are comparing the power of the model, linear or multiple regression done by SAS, versus she uses Python doing all those decision tree and there is different type of name of the models, and
Mhm.
which one gives better predictability, right?
Mhm.
And we found slightly some models that give better predictability in machine learnings,
Yeah.
but for interpretation purpose, SAS is better. Machine learning, machine learning for prediction, I say machine learning will give you better results. But machine learning cannot, those models, it varies model to model. It will not, like some models will not give you some uh, coefficients that you can use and predict, right? So there are differences.
Mhm.
Did I answer your question, Tatiana?
Yeah, yes, you did. Because with my research is all about predictability
Mm-hmm,
and not really about making inferences.
mm-hmm,
But the thing is that I'm doing a linear model, and
mm-hmm,
that linear model that I'm building, it's not really meeting all of the assumptions, but it does have good predictability when I take the log of the variable and try to
mm-hmm,
predict the log of the variable.
mm-hmm.
So I'm trying to figure out, is it okay that it's not meeting the linear assumptions, but still has high predictability based
Yeah,
off of mean squared error and other
right.
forecasting
I
elements?
think that's totally fine. And truly speaking, I have seen few papers, unless the data is very noisy, it's pretty much same results. Your linear regression and machine learning model, your predictability purpose, if you compare R square, right? Or other basic statistics, I think it's totally fine. And I know you are doing way advanced, like uh, auto correlation, right? All those you are doing it. So I think it's fine if you use or SAS. I think it's fine.
So you think that it's okay if so if my objective is predictability,
Mhm.
it's okay to not meet all of the linearity assumptions for as long as the forecasting measurements of my model are
Right. Yeah.
tagged. Okay.
Yeah. If your forecasting model is good, uh, your predictability is good, then I think it's totally fine. And I assume if it's clean data, clean data, the result does not vary much. But if it's noisy data, then machine learning has some advantages and may help to deal with all those assumptions. Right. But I think
Okay.
it's fine.
Okay.
Okay, where are you, everyone? So now I'll finish. Yes, Tatiana, thank you
Oh,
very
I'm
much
sharing.
for sharing and raising all the questions.
Do you
Yeah,
want me to unshare?
yes,
Okay.
please unshare, because the rest of the part I'll go very quickly because we need to take a break, are we? I know. We'll take a break and then
Oh,
we have corporate governance, but I'll just go over the coding a little bit in case you love SAS, because SAS is very good to create variables. And I know, like, sometimes, like, we create variables by using SAS, which is convenient, definitely better than Excel. And then for running the data, you can use eViews or Stata. So now I'll just show you a little more things. ER dummy, right? So I have this coding, you can use it. So now it's always good to control your ER and industry. And I use very basic coding, and I'll explain, the dummy variables, right? Sometimes there might be some unobserved factor. I have COVID-19 year, I have 2020, right? So there are several factors, there are several things happen that time. So I will control those by including ER dummy. So how you can do that? So if I run, see, proc freq is just to see your distribution frequency. Proc freq, that means frequency, and you want to see frequency by year, right? How many observations you have each year. So proc freq, data final, and you want to see in a table. If you do that, you will see this table, right? So we pretty much have, like, this is my percentage, cumulative percentage. So it's pretty much fairly nicely distributed, right? So now I will create dummy variables for every year, and I'll also include now dummy variables in my regression. So I did very easy coding, right? So for each year, I just call it. I started 2010, 1, 2, 3, 4, up to 2022. I have 13 years observation. So I just created a separate variable. Just name it anything. YR means year. So these are kind of identifying the years from 1 to 13. And there are several ways. You can use do loop, but I just did very layman manual. If year is 2010, then year means this is the first year. If year is 2011, then year means second year, like this way, right? But there are several ways to create that, but just for your learning purpose, very simple way, I created year variables. Now, every time I create any variables, I check it. So now I'll go here, my data, and then you have to check the variables are there. So you see here, I created year variable. This is my second year, this is my third year. Now, based on that year identifier, it's the same thing. Previously, it was like 2010, 2011, 2012, but I just named it in a different way, 1, 2, 3, 4, 5, 6. Based on this year identifier, I will create dummy variables. So you can use like manual coding, but I'm just using do loop function. It's called do loop, right? An array means like the whole data sets. And you can always use this data if you need to create. I'm creating dummy variables. This 3 dot means that would be the maximum length. Here will be like maximum like not more than 100 years or 1,000 years. So now I will create 13 variables. So you can write year 1, year 2, year 3 up to 13, but this is another way, year 1 dash year 30. And then do means do, I means I'm repeating, do loop. There will be now observations, right? I will be 1 to 13, and then if it's first year, then it will be only 1. The dummy variable will have value 1 only for the first year's observation. Others will be 0. Second year, if it's dummy variable, second year will be only. So I am creating 13 dummy variables, and you know how dummy variable works. And then I end it, right? And then if I run it, so you will see how dummy variables are created. So here, you see all those ER variables. I created the dummy variables. Year 7, this means year 7. All other observations in that column 0. Right, this is how you create dummy variables. And this I think, this just to identify the years, so you can also drop it. So I drop that I because now I will create industry dummy, and then I will control in my regression both industry and year dummy. I drop the I variable down. Let's create the industry dummy. But before that, how I can identify my industries? If you remember when I downloaded the data, I took SIC code. Now, if you see the SIC code, I'm trying to see the frequency distribution and just want to see the SIC code. If you want to go to final, you will see here, where is my SIC variables? SIC, here. SIC variable, where is it here? SIC industry, standard industry code, right? This is SIC variable, and you see SIC, these are 4 digits. That means we have so many, right? 4 digits. But creating too many dummies, you will lose your freedom of power. The more variable you add right hand side, X variables, you will lose some freedom of power observations. That's why maybe you can use 2-digit dummy, 2-digit industry code, or I did very simple first 1 digit. I will categorize industry based on first one digit. And I already know, anyone can Google it. What does it mean? Any industry that started with 5,000. Any industry, I know service industry starts with 6,000. Manufacturing starts with 5,000. So I know that first one digit code. So if I run these, all 4 digits, you see so many categories. So if I include dummies for all those, it will be too many. So do not include too many. And that's why what I did, that 4 digit, it's called substring. I just cut it. And I am creating one variable. It's called, I just name it SIC 2 digit substring. That means this SIC 2 digit will just cut and chop and take only the first 2 digits. Let's run it. Same data final. I call it SIC 2 digit and I run it. Now, if I run it, let me go to the Explorer and Final, and you will see now it looks better, right? SIC 2 digit. Still, I feel 2 digits are too many. Let's do a table, frequency table. Some journal papers, some reviewers might say you have to do 2 digit SIC fixed effect. Still, like you see many. So then I try to reduce it. Let's make it very simple. I'll use only few. And I want to also know what are the variables. So this is my own data. I just did it on purpose just to make it like name those industries based on the SIC digit. So if the SIC digit is greater than 10 or anything below 1,000, it's agriculture. If it's 9 to 15, it's mining. And when you create a variable, I'm creating this variable, I'm naming it industry. A new column I'm creating. I'm naming it industry, and that I'm also showing you how to make any text variables, right? So the column will show mining, construction, but SAS cannot create more than 3 letters. 3 letters. Number, it can take numbers. You can define how many digits you want to see. But for text, it cannot take more than 3 letters. So that's why. And this is, I made it, if the 2 digit code from 9 to 15, it's mining industry. From 14 to 20, it's construction, it's manufacturing. So I try to figure out 10 major industry categories. So I again created some variables and I'm calling it industry. And I'm running it. Let's see how the industry looks like. Go to final. And you see here the last variable I created. WHO means wholesaler. Tran means transportation. Man, manufacturing. So now I will check how the frequency distribution looks like. So I am now again creating 1 digit. I could do 1 digit at the first place, but I'm just showing it that when you create dummy, you can check it, seeing the distribution, not taking too many dummies when you are controlling this fixed effect. So now it's pure 1 digit, right? I am doing based on, because this is just the first thousand numbers, these, and I am creating dummies same way. Now my industry, those are the name. And now based on the 1 digit, now it's pretty manageable, right? The 10 industries, not bad. 10 industries, 9 dummies will be in the regression model, agriculture, construction. And you can see this is frequency, this is percentage. Now what we're gonna do, we will create the dummy same way. I use dummy 10 industry. I'm not going through the whole details, but I just use the same coding. Now this time I named it industry 1 to 10 and then the same way do loop. So I ran it and let's see. You can always check your log as soon as it looks clean, no red letter. That means it worked and we will see now. You see whole bunch of industry done. Now you can run a regression that would be way better. And we will do that and see if the results changes. Result changes. So I did it. Now this time you see year. You can write year 2, 3, 4, 5, 6. But this is another way. Year 2 to 13 means except 1 year. Because of dummy variable, you have to drop. It will drop in any way. Industry, same thing. You can write all those numbers, but I just put 2 to 10. Now let's run the regression. Results will not change that much, but it's a better model. Right. So this model is after including, you see all those dummy variable. When you will report the results, you don't need to show the dummy variable results, but you see pretty much result did not change. Rather, after controlling year and industry dummy, see your gender is little bit slightly 10% significance level. You see p-value is 0.08 and this is more than 1.65 and this is significant and interesting, right? It's negative. That means male CEOs are getting less. We have to take a break, but let's take a break and then I'll show you a few more things. Stop sharing. You guys don't ask for break. Oh my God, it's 2.5 hours. Let's take a break. Okay. So yeah, we have corporate governance paper. We'll cover that. Let's take a break and we will be back after 15 minutes. Is that fine? But the papers will finish. I have the slides. We'll go over, but the coding, I think it will be helpful. Rose, are you here? I miss you.
I'm here. I am here. I am here.
I can see you.
I'm thinking with this 15-minute, I'm going to log out completely and log back into my computer in hopes that it'll fix the issue.
Oh, sorry, you are having some issue?
Well, yeah, my camera is not working.
Okay, but your SAS is working, right?
Yeah.
Okay, great.
Yeah, everything else is working. It's just my camera is not showing anything.
Okay, and should I pause recording or stop recording? Maybe pause recording, right? Or stop. Okay, yeah. Let's take a break. We'll be back around 11:40-ish. Thank you, Erin. We'll be good. We will be good. Cheer up, cheer up. You will be good. Tatiana, you'll be good. Yeah, thank you. Kamfu, if you need any help, you let me stop.
Okay.
Stop recording.